When we talk about happiness in the brain, what we're really referring to is a set of neurochemical states. Dopamine, serotonin, endorphins, oxytocin, these chemicals shape how we feel, but they don't exist in a vacuum. They're tightly regulated by our thoughts, our environment, and importantly, our focus. There's a concept in neuroscience called selective attention. Your brain filters out 99% of what's around you to help you survive and function. What you focus on becomes your reality. So if you're constantly focused on judgment, comparison, or validation from others, you're training your brain to assign value to those inputs. And that shapes your mood, your self-impeach, and even your stress levels. In fact, there's a neural network called the default mode network. This is the part of the brain that's active when you're not focused on the outside world. It kicks in when you're daydreaming, self-reflecting, or overthinking. And what we've found is that when people are overly concerned about what others think, this network becomes hyperactive. The result, anxiety, reduced self-worth, and chronic dissatisfaction. But when you begin to detach, not in a nihilistic way, but in a deliberate, controlled way, you allow your nervous system to recalibrate. What you focus on becomes your emotional reality. This is not just a metaphorical idea, it's a neurological fact supported by decades of research in cognitive neuroscience. The human brain processes an overwhelming amount of sensory input every second. To manage this, it relies heavily on a mechanism called selective attention. This system determines what information is prioritized for conscious awareness and what is filtered out. The implications of this are profound. Whatever you repeatedly direct your attention toward begins to shape not only your thoughts, but also your emotional landscape. Inside the brain, particularly in the prefrontal cortex, there are networks responsible for determining relevance and assigning value. When you consistently focus on something, be it a task, a relationship, or a fear, your brain strengthens the neural circuits associated with that focus. It begins to assume that what you're paying attention to must be important for your survival or well-being. This is how seemingly small thoughts or habits can snowball into dominant emotional states. For instance, if you constantly fixate on how people perceive you, your brain will begin to prioritize social validation as a critical variable for safety. And this triggers stress and anxiety responses, even in neutral environments. Your emotional state is also regulated by neurochemicals like dopamine, serotonin, and cortisol. Attention influences the release of these chemicals. When you focus on things that are negative, uncertain, or uncontrollable, your limbic system, especially the amygdala, interprets that input as a threat. This leads to the release of cortisol, the primary stress hormone, which then feeds back into your attention system and causes even greater vigilance. In contrast, when you focus on something that you can control or find meaningful, dopamine pathways are activated, enhancing motivation and well-being. The takeaway here is that attention is not passive. It is an active force that either escalates or de-escalates your emotional states based on what you allow to dominate your internal environment. Consider also how attention interacts with memory. When you focus repeatedly on negative events or perceived failures, your hippocampus stores these with increased salience, making them easier to recall in the future. This creates a feedback loop where your memory becomes skewed toward emotionally charged, often negative content, reinforcing a distorted view of yourself and the world. On the flip side, deliberately shifting your attention toward positive actions, solutions, or even neutral observations can start to rewire these patterns, making it easier to access more balanced or constructive thoughts over time. In practical terms, this means that choosing where to place your attention is one of the most powerful decisions you can make for your mental and emotional health. You're not just observing your world, you're actively constructing it. The simple act of shifting attention away from what drains you and toward what aligns with your values and goals can begin a cascade of neurological changes. These changes influence everything from your stress levels to your motivation to the way you experience daily life. An overactive default mode network leads to anxiety and overthinking. The default mode network, or DMN, is a system of brain regions that becomes active when the mind is at rest and not focused on the external environment. It includes the medial prefrontal cortex, posterior cingulate cortex, and parts of the parietal lobe. While its function is crucial for internal thought processes such as self-reflection, memory consolidation, and envisioning the future, problems arise when this network becomes chronically overactive or dysregulated. The DMN is most active during moments of mind wandering, introspection, and rumination. When individuals are not engaged in goal-directed tasks, this network essentially takes over. In healthy functioning, this allows for creativity, planning, and personal insight. However, when overactivated, it often leads to repetitive negative thought loops, excessive self-referencing, and fixation on hypothetical scenarios, hallmarks of anxiety and overthinking. From a neurological standpoint, this is a maladaptive use of an otherwise useful brain system. Studies using functional MRI scans have shown that individuals with anxiety disorders, depression, and high stress levels often display elevated baseline activity in the DMN. This hyperactivity is associated with intrusive thoughts, an inability to disengage from internal dialogue, and a tendency to dwell on perceived failures, social comparisons, or potential future threats. Essentially, the brain is trapped in a cycle of what-ifs and should-haves with little relief or resolution. This cognitive state is exhausting and consumes mental resources that would otherwise be used for focus, decision-making, and emotional regulation. What makes this even more compelling is how the DMN interacts with the limbic system, particularly the amygdala. When overactive, the DMN can feed emotionally charged content into the amygdala, which interprets it as a threat. This activates the sympathetic nervous system, increasing cortisol levels and reinforcing a state of hypervigilance. In other words, an overactive DMN doesn't just affect your thoughts, it alters your physiology, creating a body-wide stress response, even in the absence of external danger. From a behavioral perspective, people experiencing an overactive DMN tend to become less present and more reactive. They may struggle to engage fully in conversations, work tasks, or even leisure activities. Their internal narrative becomes louder than the world around them, pulling them into a loop of introspective noise that is difficult to break. This often leads to mental fatigue, irritability, and sleep disturbances, further compounding the problem. Tools such as focused attention, mindfulness, and breath work have been shown to help quiet the DMN. These practices engage other brain networks like the task-positive network and the salience network, which help shift attention back to the present moment. Functional shifts in these networks reduce DMN dominance and promote healthier cognitive processing. Movement and exercise also play a role by stimulating neurochemicals that inhibit excessive DMN activity and enhance executive function. Ultimately, understanding the role of the DMN gives us insight into why we sometimes feel trapped in our own minds and offers a biological explanation for the patterns of anxiety and mental exhaustion many people experience on a daily basis. Detachment shifts your brain from stress to calm via the autonomic nervous system. The autonomic nervous system is responsible for regulating involuntary physiological processes, including heart rate, respiration, digestion, and arousal. It consists of two primary branches, the sympathetic nervous system, which mobilizes the body's fight or flight response, and the parasympathetic nervous system, which governs rest, recovery, and restoration. When we experience chronic stress or emotional overload, often driven by excessive caring about outcomes, judgments, or uncontrollable situations, the sympathetic branch remains overactive, leading to a range of physical and psychological consequences. Caring deeply about things outside of our control places continuous demand on the brain and body. This demand is interpreted as a form of threat, even when it's purely psychological. The brain, particularly the hypothalamus, triggers a stress response that floods the body with cortisol and adrenaline. These neurochemicals are helpful in acute danger, but harmful when constantly present. Persistent activation of this stress system can lead to anxiety, sleep disturbances, digestive issues, and impaired immune function. Moreover, it disrupts clear thinking by limiting activity in the prefrontal cortex, which is responsible for executive decision-making and emotional regulation. Detachment, when practiced consciously, signals to the brain that the perceived threat is no longer relevant or dangerous. This creates space for the parasympathetic nervous system to engage. One of the most important nerves involved here is the vagus nerve, which plays a critical role in calming the heart, slowing the breath, and reducing inflammation. As vagal tone improves through intentional detachment practices, heart rate variability increases, a key biomarker of resilience and emotional balance. The shift from sympathetic dominance to parasympathetic regulation is not just a feeling of calm, it's a measurable physiological transformation. Neuroimaging studies have shown that people who regularly practice forms of detachment, whether through mindfulness, cognitive reframing, or breath work, exhibit reduced activity in brain regions associated with reactivity and emotional volatility, such as the amygdala. Simultaneously, activity increases in the prefrontal cortex, improving cognitive control and the ability to pause before reacting. This enhances decision-making and reduces impulsive behavior, especially in high-stress environments. Detachment doesn't mean ignoring responsibilities. It means redefining how the brain evaluates urgency and importance. There is also a link between detachment and neurotransmitter regulation. As the parasympathetic system becomes more active, the release of calming neurotransmitters like GABA and serotonin increases. GABA in particular acts as a neural inhibitor, reducing overactivity in brain circuits associated with worry and tension. This helps the brain and body move toward a state of relaxed alertness, where energy is preserved, focus is sharpened, and emotional stability is restored. In contrast, constant attachment to outcomes, opinions, or control over others floods the system with dopamine spikes and crashes, creating a roller coaster of emotional highs and lows. The act of mentally stepping back, of creating a cognitive boundary between what is within your sphere of influence and what is not, activates a different mode of being. It is a state in which the brain operates more efficiently, the nervous system becomes more regulated, and the body begins to repair and recharge from the inside out. Reframing helps the brain regain executive control and clarity. The human brain is constantly interpreting and assigning meaning to experiences, and this process is largely governed by the prefrontal cortex, which is responsible for executive functions like planning, reasoning, and decision-making. When we're caught in emotional reactivity or stressful situations, the brain often defaults to habitual thought patterns rooted in fear, threat detection, or past experiences. These automatic responses are typically regulated by subcortical structures like the amygdala. Reframing allows us to interrupt these loops and consciously redirect mental energy toward more constructive interpretations. At the neurological level, reframing engages the top-down control of the prefrontal cortex over the limbic system. This means that instead of letting the emotional centers of the brain dictate our reactions, we use higher-order thinking to reinterpret the situation. This act of cognitive flexibility is associated with increased activity in the dorsolateral prefrontal cortex and decreased activity in the amygdala. The result is a greater sense of emotional regulation, reduced impulsivity, and improved decision-making. It essentially restores balance between the rational and emotional systems of the brain. Reframing also affects how the brain releases and regulates neurochemicals. When we interpret an event as threatening or overwhelming, stress hormones like cortisol and norepinephrine are released, putting the body in a heightened state of alert. However, when we successfully reframe a challenge as an opportunity for growth or learning, we activate reward pathways that release dopamine. This not only shifts our mood, but also increases our motivation and ability to act with purpose. In this way, reframing is not about denial or forced positivity. It is about changing the brain's internal chemistry through deliberate reinterpretation. One of the most powerful aspects of reframing is that it builds psychological resilience over time. Each time you consciously reinterpret a stressful or negative event, you strengthen neural pathways associated with cognitive control and emotional regulation. This neuroplasticity makes it easier for the brain to default to more balanced thinking in the future, reducing the grip of automatic negative thoughts. Reframing doesn't eliminate difficulty, but it reduces the emotional charge associated with it, which in turn makes it easier to move forward without being paralyzed by fear or uncertainty. From a behavioral standpoint, reframing also increases our tolerance for discomfort. By choosing to view discomfort as information rather than a signal to retreat, we train the brain to stay engaged under pressure. This has direct applications in performance, relationships, and mental health. People who regularly practice reframing tend to experience lower levels of chronic stress, higher levels of perceived control, and a more optimistic outlook on life. These aren't just subjective benefits, they're mirrored in measurable brain activity and physiological markers such as reduced heart rate and lower cortisol levels. The act of reframing can be as simple as asking better questions. Instead of, "Why is this happening to me?" try, "What is this teaching me?" This shift in language alters the brain's orientation from victimhood to agency. It places you back in the position of an active participant in your own experience, which reactivates executive control systems and promotes clarity of thought. Widening your visual field reduces fear and restores emotional balance. This might seem like a subtle or even irrelevant action, but it has profound effects on how the brain and nervous system respond to stress. The visual system is tightly linked to the autonomic nervous system, which controls physiological states of arousal or calm. When you're stressed, anxious, or in a state of hypervigilance, your visual field narrows. This is an evolutionary adaptation designed to help you focus on potential threats. The pupils constrict and your gaze locks onto a specific point in space, usually straight ahead or slightly downward, which activates a sympathetic response in the body. However, when you consciously widen your visual field, what's sometimes called panoramic vision or optic flow, it sends a signal to the brain that the environment is safe. You are no longer in immediate danger. So the nervous system begins to shift out of the fight or flight state. This happens through downregulation of the sympathetic system and increased activation of the parasympathetic branch, particularly through vagus nerve engagement. As a result, heart rate slows, breathing deepens, and cortisol production begins to decrease. These physiological changes are all part of what leads to emotional balance. Neuroscience research has shown that the visual system is not just passive input, it's an active modulator of brain states. Specific areas of the brain, such as the superior colliculus and the visual cortex, interact with the limbic system to adjust emotional tone based on visual input. When your visual field is narrow and tense, it reinforces internal states of anxiety and hyper-focus on negative thoughts. Conversely, when the visual field is expanded, such as by looking at the horizon or taking in a wide landscape, the brain interprets the scene as less threatening, and this helps shift internal emotional dynamics almost immediately. This mechanism is not limited to natural environments. Even in indoor spaces, consciously softening your gaze and taking in more peripheral vision can alter your mental state. This is especially useful in situations where you feel overwhelmed or overstimulated. By shifting from a focused tunnel vision mode into a more relaxed and broad gaze, you interrupt the loop of internal stress signals. This isn't just psychological, it's grounded in measurable physiological responses, including lowered blood pressure and reduced muscle tension. Visual field expansion also influences how attention is allocated in the brain. The default mode network tends to dominate when focus becomes internally directed and overly narrow. By widening the visual field, you engage networks responsible for external awareness and spatial orientation, which pulls cognitive resources away from excessive rumination or negative thought spirals. This not only improves mood, but also enhances situational awareness, allowing for better decision-making and emotional control. Athletes, military personnel, and high-performance individuals often train this skill deliberately because of its immediate impact on state regulation. When under pressure, maintaining a wide field of view helps prevent panic and keeps the mind in a more adaptive and responsive mode. It is one of the fastest and most accessible ways to self-regulate, requiring no tools, no training, just awareness and intention to engage the full capacity of your visual system. Internal dopamine loops build resilience and true motivation. Dopamine is often misunderstood as the molecule of pleasure, but in reality, it is the molecule of motivation, drive, and pursuit. It is released in anticipation of reward rather than the reward itself. The brain uses dopamine to reinforce behaviors that are considered valuable, encouraging repetition of those actions. When dopamine release becomes tied to external validation, such as social media likes, praise, or material success, it creates dependency. The motivation system becomes externally regulated, meaning you only feel driven or excited when there's an outside stimulus providing reinforcement. Internal dopamine loops function differently. They are generated when the brain begins to associate dopamine release with effort itself rather than the outcome. This shift is powerful because it creates a sustainable and self-reinforcing motivation system. The neural pathways involved here include the mesolimbic and mesocortical dopamine systems, especially the projections from the ventral tegmental area, VTA, to the nucleus accumbens and the prefrontal cortex. These areas are responsible for goal-directed behavior, decision-making, and long-term planning. When internal loops are established, effort becomes intrinsically rewarding, even in the absence of immediate results. Training the brain to access internal dopamine begins with deliberate focus on process over outcome. Neuroscience shows that when we mentally reward ourselves for engaging in a difficult task, regardless of success, dopamine is released. This enhances neuroplasticity, making it easier to repeat the behavior in the future. Over time, the brain begins to associate the effort itself with satisfaction. This shift is foundational to resilience because it makes the individual less susceptible to demotivation from setbacks, delays, or failure to receive external validation. In contrast, external dopamine reliance creates volatility. The absence of praise or recognition results in a drop in dopamine levels, leading to demotivation and disengagement. This is often seen in environments where people rely heavily on approval, status, or outcomes for their sense of progress. Their motivation system becomes fragile and their emotional state fluctuates with external events. Internal dopamine loops buffer against this by providing a stable baseline of motivation that is largely immune to the noise of the outside world. There is also a physiological advantage to internal loops. When effort-based dopamine release is activated consistently, it supports better regulation of the autonomic nervous system. This means improved focus, reduced emotional reactivity, and enhanced ability to recover from stress. Individuals with strong internal loops often display higher levels of persistence, self-discipline, and emotional balance, all of which are critical components of long-term success and well-being. These traits are not simply psychological, they are underpinned by a finely tuned neurochemical system that rewards consistency and engagement over outcome and applause. Tools like goal chunking, self-generated reinforcement, and mindful reflection on effort can help build these internal loops. Even small acknowledgments of progress can trigger dopamine release when paired with intentional thought. Over time, this rewires the brain to seek growth and learning rather than mere achievement, making motivation a trait rather than a state.